Okay, class 9 students. Today we will try to study more about waves. Actually, last day we have started the idea of waves, and today we will continue our discussion on waves. So, what is wave? Last day I was telling you what is wave. Today we will continue our discussion of wave, and we could understand that different types of wave are there, but the wave characters remain same. That means characters of wave is not different. Always wave characters are same. What is the meaning wave characteristics? Characteristics of wave means its maybe speed, its frequency, its wavelength, its amplitude, its time period. That is always same. In same way we can define. There is not much difference uh, in frequency, wavelength. That means definition part is same. Characteristics of wave, that is very important topic that gives the idea that what could be the important points of wave. But before that, we should understand more about sound wave. That is, sound wave is a longitudinal wave, and if you are talking about sound wave as longitudinal wave, then how longitudinal wave is propagated, how sound wave is propagated, we should understand that thing. That will be very important point of discussion. Propagation of sound wave or propagation of longitudinal wave. Propagation of sound wave or propagation of longitudinal wave, because sound wave is a longitudinal wave. So when we are talking about longitudinal wave, then it is clear that the definition part of longitudinal wave says that it is that wave in which the particles of the medium vibrate to and fro in the direction of the wave. So we remember that is the definition part. So we will start from the definition part. Longitudinal wave is that wave in which particles of the medium vibrate to and fro in the direction of propagation of wave. So how it propagates? That actually compressions and rarefactions are produced. When sound wave propagates, when longitudinal wave propagates, there are some region where the density of the particle is more, and there are some region where the density of the particle is less. So those region which have a higher density, this is called compression region. So when longitudinal wave propagates, then compression and rarefactions are produced in the medium. So compressions and rarefactions are produced in the medium means what? Compressions are the regions of higher density of particles. कोई है दरवाजा खोल दो. Higher density of particles and rarefactions are the regions of lower density of particles. Lower density of particles. Lower density of particles and higher density of particles. Compression region where particles are very close to each other, and rarefaction region where particles are apart from each other or farther from each other. This is very important point to understand. So between two compressions, maybe the distance is equal to the wavelength of the wave. But what are compressions and what are rarefactions? Let us study this. Think that it is a tuning fork, and tuning fork is plugged. So when it will be plugged, what will happen? It will vibrate. So when it is going to vibrate, then the air particles which are closer to the tuning fork will get together, will come closer. So those regions are called actually compression regions. So when we see so these are when particles brought closer to each other, and these particles when brought closer, this region is actually compression region. And then when these particles is coming to their place, then what will happen? Then here rarefaction region will be produced. So rarefaction is the region of lower density of particles. Again, the compression region is produced. And again rarefaction region is produced. So this compression rarefaction continues, goes on continuation, and sound energy or the wave involved in longitudinal wave, the energy involved in longitudinal wave is propagated from one point to other point in the medium. You know this, you can see tuning fork. This is called tuning fork. You can see in the lab. So this is tuning fork. When this is vibrating, then sound wave is produced. So when sound wave is produced, so what will happen when sound wave is produced? Sound wave means compressions and refractions are produced. That is very important. Sound wave means compressions and refractions are produced. So when we are talking about sound wave, then actually we are talking about compressions and refractions. That is very important. So compressions are region of higher density, and if density is more, then pressure is also more. And rarefaction is the region of low density of particles. If density is lower, then pressure is also lower. So in the normal case, when there is no sound wave, when there is no longitudinal wave in the medium, density and pressure remains same. That is normal pressure of the medium. That is normal pressure, maybe. This is normal pressure point. Now, if we will talk about the variation of density or pressure with distance, then what we see? There will be some points of higher density. And there will be some points of lower density. So when we talk about compression region, then of course these are the points of higher density. And maybe if you are talking about rarefactions, so these are the points of lower density. Again, higher density, and again lower density, again higher density, and this way actually when we give the graph between the variation of density and pressure with distance, then what we see, the variation of density and pressure with distance is actually a graph that has got wave character, or this is the waveform we can say. So when we represent any wave, actually we represent by waveform. So this is the waveform that is concerned. Actually this waveform is the graphical representation of longitudinal wave, and that is graph between density and distance. With distance there is variation of density. That is very important to understand here. Graph between density variation and distance. Distance from what? Distance from source of wave. Here this tuning fork is the source. Initially it is in normal condition. Maybe this was the normal condition. and once we are striking the tuning fork comes into vibration. When it comes into vibration, then what happens? There are region vibration setup, particles come closer, and again particles moves further. So this coming closer, and after few seconds it will move again to their normal position, giving energy to next layers. So this goes on continuation. That is actually here the way this longitudinal wave moves. This is the way here longitudinal wave moves. That is very important to understand. So how it moves? Through compression and rarefaction. Through compression and rarefaction. That is very important. So we should understand this. The character of longitudinal wave and the graphical representation of longitudinal wave is through compression. These are the compression higher density region, and these are the rarefaction lower density region. Compression, rarefaction, compression, rarefaction. Between these two compression, the distance is called wavelength. Also between two rarefaction region, the distance is called wavelength of the wave. So what is wavelength in case of longitudinal wave? Wavelength in case of longitudinal wave is the distance between two consecutive rarefaction or distance between two consecutive compression. That is in case of longitudinal wave. That is the case of sound wave, because sound wave is a longitudinal wave. But what will happen in case of transverse wave? That we will discuss later on. But one thing is very important, that the source of sound here, it is tuning fork. Tuning fork actually a apparatus you can see in the lab. When it is struck, then vibrations are produced that creates sound wave of certain frequency. That means frequency means number of oscillations per second. That is frequency. But there are other source of sound also. Our vocal cord is also the source of sound. Strings, when we plug the string, a string in guitar, that is also source of compression and rarefactions. Sound is produced. So when we drop a stone, a pebble in the pond, then that also produces some wave, some sound wave. So there could be different source of sound wave, but in all cases, how it propagates in the medium. Sound wave could propagate in gas medium, in atmosphere. It could propagate in liquid medium, in water, or in different liquid medium, or in gaseous medium also, in air, or in solid medium also, like steel, aluminum, copper. And speed of sound varies, but frequency remains same. Frequency does not depend on the medium of propagation. Frequency of the wave depends on source of the sound, not the medium in which sound wave propagates. Source of sound wave. not the medium of propagation. Not the medium of propagation. That is very important. Okay, students. Thank you.